All right, final video, 11.3. And this is, oh shoot, what's the title of it? It is called Data Distribution. So I'll write that down. Data Distribution. Okay. With that being said, we're going to go over the basic of all basics. And you've been doing this stuff since middle school, maybe even earlier. The mean is just a different word of saying the average. Now notice this formula coming up has the word mean in it. So you got to know what the word mean means in order to be successful with the formula. So if we got a list of numbers, and I'm just keeping it easy on you because I think we could bore you to death with this, but you just take the number of numbers. So you add them, so 2 plus 5 plus 6 plus 7, and you divide by the number of terms in that data set or list. If you want. So we got 2 plus 5 is 7, 7 plus 6 13, 13 plus 7 is 20, divided by 4 is 5. So that would be my mean. Okay. All right, with all that being said, median. Well, the first thing, there's a little twist in the world of median is you got to put things in order, smallest to highest. So 4, done with that. 6, done with that. 10, done with that. 27, done with that. And then 32, that's 27. Notice we got 1, 2, 3, 4, 5 numbers. Median means middle after you've organized them in chronological order. So that would just be the obvi 10. Go on to the next one. A little twist here. We got a 1, done with that. Then a 4, done with that. Then a 11, done with that. 17, done with that. 68, done with that. Notice we've got, in this case, well, actually, 1, 2, 3, 4, 5. I didn't mean that. Let's add one more random number, 12. So that would be 1, 4, 11, 12, 17, 68. This is what I really wanted to do. This one we had an odd number of things. 1, 2, 3, 4, 5. This thing we have 1, 2, 3, 4, 5, 6. So there we go. So let's say 12 is part of that list. So we're done with it. We got it in our list. Well, notice these two numbers are really in the middle of our list. So if that's the case, you have an odd number of things in your list, you just take the average of those two things, which is pretty obvious. It's 11.5. So that's how you do the median for even number of items in your data set. Mode. Really, that means what's the most popular number. A 1 shows up twice. A 6 shows up, so a 1 shows up twice. A 6 shows up once. A 7 shows up once, and a 9 shows up 3 times. What's the most popular number? The 9. There's your mode. Median, mean, median, mode. All right, let's get on to some stuff you may have never seen before. Standard deviation. Standard deviation, in a way, is connected to your average in a way, because our average of these three numbers is just 5. That's our average. What the standard deviation is the formula to determine error and how close each number is to the average in a way. Now, I'm going to let the numbers speak for themselves, and I'm going to start with this problem. And this little symbol is a butchered way. There's a symbol that represents standard deviation, and it equals this crazy formula. This means the sum of. So we got the sum of this. X is this first number minus the mean. Well, we got 1, 2, 3, 4, 5 things to figure out the average of. I'm going to go ahead and take my handy dandy calculator, and let's see if we can add these together. So 82 plus 93 plus 98 plus 89 plus 88. Enter. divided by, maybe I made the numbers nice and easy, I think I did, 5 is 90. Yeah, I definitely made these. All right, so we got 450 divided by 5, and we got 90 as our mean. So that works out pretty nice. Now what we're going to concentrate on is this. So we'll talk about this in a minute, but let's figure out what this means. It means take x, your first number in your list, follow the formula, subtract the mean, square it. Well, that'd be negative 8 squared is 64. Let's go to the next number. 93 minus 90 squared. Remember, this mean is our average. That's why it's showing up every time. 93 minus 90 is 3. 3 squared is 9. 98 minus 90 squared is 8 squared, which is 64. Come on, paper. And now we got 89 minus 90 squared, which is just 1. Negative 1 squared, which is 1. 88 minus 90 squared. So we got negative 2 squared is 4. Now, what does this symbol mean? It means the sum. So we have to take all of these answers to this and add them up. 73, let's go 128 plus 9 is 137, 138, 142. One more time. 5, 69, 78, 78, 12, that works, 142. Now, so I get the square root of 142 all over n, and that's the number of numbers in your list. 1, 2, 3, 4, 5. So I'm going to take my calculator, turn that bad boy on, and here we go. Take the square root of 142 divided by 5. So I get 5.3. I'm going to round it. Well, I'll take it to the, I think in the world of standard deviation, they take it to the thousandths often. So we'll leave it right there. All right, now to understand this, let's take these numbers. 3, 3, and 3, and 3. We take it and put it in our, first thing we do is we're going to figure out our mean. Well, 3 plus 3, pretty obvious, plus 3 divided by 4 is 12 over 4, and lo and behold, amazing, our mean is 3. If we just followed the formula, and we went just like this, take the first number, 3 minus 3 squared, well, that's 0. 3 minus 3 squared, going to the second one, 0. 3 minus 3 squared, 0. 3 minus 3 squared, 0. And then we add all of these up, we get 0. Divide by the number of numbers, which is 4 in this case. Doesn't matter how many numbers are in there. Anything, 0 divided by anything is just 0. Notice our answer is 0. Well, that's because they did not deviate from the average at all. So this back up here, 5.329, is your standard deviation. It's kind of like your average deviation of each number, if you want to think of it that way. So with that in mind, a couple more things, and then we're done. So we've got these three pictured. Skewed or symmetric. This is easy, because if you kind of go right down the middle, and you notice this is kind of a mirror image of this. So that is the easy one, symmetric. Skewed, you either have skewed left or you have skewed right. Now, it's all about the tail. So if you notice, this is an animal, the tail would be right here. This is skewed left. This guy's tail is this way, so that would be considered skewed right. It's about the tail, it's not about the peak. So keep that in mind. This little, I don't know, doesn't match my way of thinking. So now they're going to say classify the data set. They're going to say, is it symmetric, is it skewed left, or is it skewed right? Well, the hard part is just getting your thoughts organized to make a nice organized chart. Here's your strategy. Scan, look for your lowest number, 64. So my low number is 64. My high number, if I go through this whole list, 120, looks like it's a winner, shows up twice, 120. And if I think, you know, approximately 60 separates these two, so I'm going to make this chart, and I'm going to go in sections of 10. see if I can fit this in here. So 10, 20, 30. Oh, no. 60, 70, 80, 90, 100, 110, and 120. So that captures all of our numbers. So, how many numbers are in between 0 and 60? Well, I've got 1. Well, none. How many numbers are between 60 and 70? Well, 1. Is that it? So if we go 1, 2, 3, and I don't know if this chart's going to be real good or real bad, but we'll make sense of it by the time we're done. So we got none between 0 and 60. We got 1 between 60 and 70. Now between 70 and 80, I'm just scanning. Got 1, 2, 3. So that jumps up to here. Now between 80 and 90, 1. So it kind of comes back down to here. Now between 90 and 100, 1, 2, 3, 4. So that jumps way up here. And between 100 and 110, so we got 1. That's it. And then we got 110 and 120. 1, 2, 3, 4, 5. So that thing skyrockets way up here. Now, in a traditional easy graph, this would have been up here, this would have been up here. But as you can see, this thing, in a way, I know it goes like this and then down and then like this and then down. But generally speaking, you can kind of look at the peaks here. And you can see this would be considered skewed left. Okay? Just, there we go. And that finishes things. If these numbers would have just put, you know, quite a few more numbers in this space, quite a few numbers in this space, it would have been easier to just see that progression. But in a sense, we're just looking at these, and so it's kind of on its way up. Technically, like this. I don't remember what this one was. And then this. And then this. But you can kind of see the general progression is going up. Maybe that's a bad example. Hope your book examples are a little better and easier to read. But I hope that gets you off the ground. Also, a little apology. The book's problems are nasty. They take forever. So on your quiz or your test, there's no way I'm going to pound you with the problems that resemble the book. It's going to resemble more like this, because I don't want you to take up half your class time just working on one problem. So that's it, you guys. Reach out for help if you have any questions. Like and subscribe if you're wanting to make me go viral. Thanks a lot, especially to Ryan Sheffer.